Before we begin our Lesson 11.9 guided notes on multiplying binomials with radicals, I wanted to finish this last problem, number 14, from your Lesson 11.8 notes. So if you don't have those, maybe stop the video for a second and grab it and write this problem down, and then I want you to try it and make sure you do get this answer. It's the square root of x over a minus the square root of a over x. Your answer, it can look two different ways. It can be x times the square root of ax minus a times the square root of ax over ax, or you might have the square root of ax times the difference of x minus a all over ax. Okay. So now that we finished that, I'm going to go to 11.9 and we're going to start those notes. And it says multiplication of binomials containing radicals. The objective is to multiply binomials containing square root radicals and rationalize binomial denominators that contain square root radicals. So in this lesson, we're going to think back to when we did polynomials and we multiplied those, which was either at the end of our semester, our first semester, or the beginning of our second semester in January. So we're going to be doing the same thing as we did when we multiplied polynomials, specifically binomials, where we use FOIL. We're going to do that with the radicals. So our first practice problem is the square root of 7 plus 5 times the square root of 7 minus 5. So when we think about FOIL, we think about first, last, outer, inner. So first would be the square root of 7 times the square root of 7, which is the square root of 49. Then we go to outer, negative 5 times the square root of 7. You cannot multiply those together because one is a radical and one is not. The inner is 5 times the square root of 7. And the last is 5 times negative 5, which is negative 25. Okay, so the square root of 49 is 7. What happens to our middle terms? Well, one's a negative 5 square root of 7 and the other one's a positive, so they cancel. So I have 7 minus 25, which is negative 18. All right, let's look at the next one. 6 plus the square root of 11 times 6 minus the square root of 11. Again, when we FOIL, we're going to first, 6 times 6 is 36. Outer, 6 times negative square root of 11 is negative 6 square root of 11. Inner, square root of 11 times 6 is 6 square root of 11. And last is square root of 11 times negative square root of 11, which is negative square root of 121. Again, look what's happening to our outer and inner terms. They're canceling. So we get 36 minus the square root of 121 is 11. So we get 25. Okay, so these you can think of as the difference of squares, where basically you're just squaring the first and you're squaring the last. And I'm fine with you doing it that way. I don't need you to do FOIL all the way out. I just wanted to remind students who may have forgotten how to do that. But essentially you're just squaring the first and the last and then combining from there. Okay, let's look at the next one. We have the sum of 4 and the square root of 6 all squared. So this is the square of a binomial. Remember, this means this binomial written out twice. Okay? You can use the shortcut if you want, which is squaring the first, doubling the inside, and then squaring the last. But I'm going to FOIL it. 4 times 4 is 16. 4 times the square root of 6 is 4 square root of 6. The square root of 6 times 4 is 4 square root of 6. The square root of 6 times the square root of 6 is 36. So we have 16. These like terms we add because they are both plus 4 square root of 6. We get 8 square root of 6 plus the square root of 36 is 6. When I combine like terms, I get 16 plus 6 is 22 plus 8 square root of 6. And order doesn't matter. If you had 8 square root of 6 plus 22, that would be fine as well. The next one, 3 times the square root of 3 minus the square, is it the square root? Yes, it is. The square root of 10 all of that squared. So this is also the square of a binomial. It means 3 square root of 3 minus the square root of 10 times 3 square root of 3 minus the square root of 10. I wrote that back. All right. If we FOIL again, we're starting with first. First means the outside. 3 times 3 is 9. The inside, we can multiply. 3 times 3 is 9. We go to the outer, and we get 3 times the square root of 3 minus the square root of 10. So this becomes negative 3 square root of 30. Inner, we get negative square root of 10 times 3 square root of 3, which is also negative 3 square root of 30. And then we get a negative square root of 10 times negative square root of 10, which is a positive square root of 100. These middle terms are like terms. This is a perfect square, so this becomes 9 times 3. This becomes minus 6 times the square root of 30. And 100 is a perfect square, it's 10. There are no perfect square factors in 30, so we leave that just like it is. And we get 27 minus 6 square root of 30 plus 10. And we combine those like terms and get 37 minus 6 square root of 30. Okay, I'm going to do one more with you, and then I'm going to let you try a couple on your own. All right, number 5. 5 square root of 3 minus 2 square root of 6. 5 square root of 3 plus 2 square root, I don't know why I put that in parentheses, plus 2 square root of 6. So I look at this and I see it's a difference of squares. So again, I can use the shortcut, and I might do it this time just to show you the shortcut. It means that your middle terms are going to cancel out. So we really only need to square the first and the last. So I do 5 times 5 is 25. Square root of 3 times square root of 3 is 9. Now I'm doing last. Negative 2 times positive 2 is negative 4. Square root of 6 times square root of 6 is 36. 9 is a perfect square. It is 3. And 36 is a perfect square, and it is 9. So 25 times 3 is 75, and 4 times 9 is 36. And when I subtract those, I get, what do I get? 39. 39 for my answer there. Okay, so let's have you try a couple and see if you get the correct answers. You have 7 times the square root of 5 plus 11 times 2 times the square root of 5 minus 6. Your answer should be 4 minus 20 square root of 5. Number 7 is 7 times the square root of 13 plus 2 square root of 6 times 2 square root of 13 plus 3 square root of 6. It looks like your answer is 218 plus 25 times the square root of 78. Okay, so do those and see how you do on those, and I can always help you if you need help. Okay, so let's go down and talk about the conjugate. Sometimes it is necessary to multiply by the conjugate to rationalize the denominator. 4 minus the square root of 5 and 4 plus the square root of 5 are conjugates. Okay, so you should notice that the only difference between the conjugate is their sign. If you notice, one was subtraction, the other one is addition. So if you're given addition, you're going to use the same thing with subtraction to conjugate it. All right, so let's practice. Why is this important? Because it's going to help us rationalize the denominators. I have 1 over 2 plus the square root of 3. This is a quantity, so I can't just multiply the numerator and denominator by the square root of 3. I have to multiply it by the conjugate so that I can properly solve it. So I get 2 minus the square root of 3 is the conjugate. Whatever I do to the denominator, I do to the numerator. So in the numerator, when I multiply 1 by that, I just get what I had, 2 minus the square root of 3. And the denominator, it creates a difference of squares. Remember, difference of squares means the outer and inner are going to eliminate. So I'm only doing the first and last. 2 times 2 is 4. Positive square root of 3 minus or times negative square root of 3 would be negative square root of 9. So this becomes 2 minus the square root of 3 over 4 minus 3. And 4 minus 3 is 1, so you don't even have to write that denominator because it's an understood one when nothing's there. Number 2, 5 divided by 3 times the square root of 7 minus 5. Okay, again, I need the conjugate. The conjugate is 3 times the square root of 7 plus 5. The only thing that I change for a conjugate is the operation. All right, in the numerator, I have to distribute the 5 to both. So I get 5 times 3 is 15, square root of 7. 5 times 5 is 25. And the denominator, again, is a difference of squares. So that means first, and I can do last. The first is 3 times 3, which is 9. 7 times 7 is the square root of 49. So it's 9 times the square root of 49. And then negative 5 times 5 is 25. Okay, so let's look at this. The square root of 49 is 7. So we end up with 15 times the square root of 7 plus 25 all over 63 minus 25. And 63 minus 25 is 38. Now, if I could simplify something, it would have to simplify by the 15, the 25, and the 38. And of course, the square root of 7 does not have any perfect square factors, so I'm done. All right, the next one is the square root of 5 minus 2 over the square root of 3 plus 1. Again, I have to multiply by the conjugate. The conjugate of the square root of 3 plus 1 is the square root of 3 minus 1. I do it to the numerator and denominator. When I multiply the numerator, I'm FOILing. It is not a difference of squares, so it's the square root of 5 times the square root of 3 is the square root of 15. The square root of 5 times negative 1 is negative square root of 5. The square root of 3 times negative 2 is negative 2 square root of 3. And negative 2 times negative 1 is positive 2. All over, this is a difference of squares. So this becomes the square root of 3 times the square root of 3 is 9. And 1 times negative 1 is negative 1. Let's look and see what we can clean up on the top. There's no perfect square factors in 15. There's no perfect square factors in 5. None of the radicans are the same. So this is just one big long numerator, just rewritten. Over, that becomes 3. 3 minus 1 is 2. And that's all we can do. We can't simplify anything from the top because you would have to be able to simplify something from every term. Okay, 4 square root plus the square root of 5 over 3 minus the square root of 5. Multiplying by the conjugate, 3 plus the square root of 5, top and bottom. I'm going to FOIL the top. When I FOIL, it's 4 times 3, which is 12. 4 times the square root of 5 is 4 square root of 5. 3 times the square root of 5 is 3 square root of 5. And the square root of 5 times square root of 5 is square root of 25. On the bottom, it's a difference of squares. 3 times 3 is 9. Negative square root of 5 times positive square root of 5 is negative square root of 25. On the top, it looks like I have some like terms right here in the middle, and I also can make the square root of 25 5. So 12 plus 5 is 17, and then 4 square root of 5 plus 3 square root of 5 is 7 square root of 5. All over the square root of 25 is 5 all over 4. Okay. Let's see. There's one final problem here that I want you to try to do, and I'm going to run out of time again probably. It says show that 4 minus the square root of 7 is a root to the equation x squared minus 8x plus 9 equals 0. So for the x, I'm sticking in 4 minus the square root of 7, and I'm squaring it, times 8, 4 minus square root of 7. So wherever there's an x, I'm sticking that in. When you solve this, you should end up getting 32 minus 32 equals 0, and that is true. If you have problems